Our objective for today, I can solve a system of linear equations by graphing. Let's read together. 1, 2, 3. I can solve a system of linear equations by graphing. So moving on, yes? Everybody go like this? Bear with me because we're about to take off. Bam, let's go. So first of all, let's clarify what system of linear equations are. So in your prayer model, you're going to write system of linear equations. What are they? Now, by now, second semester, hopefully, we should understand every word in the definition of our concepts. All right? So let's go over the definition. Here it goes. Definition. A set of two or more. Do we know what a set looks like? Yes, we've been using sets already. Is that correct? Two or more linear equations. Do we know what linear equations look like? Yes. That have the same variables. Do we know what variables look like? Yes. So here goes the whole definition. A system of linear equations is a set of two or more linear equations that have the same variables. Examples. Here they give us the set of y equals 3x plus 1 and negative 4x plus 2y equals 6. Second example. Negative y equals x minus 5 and y equals 2x plus 1. But if you notice on this one, they didn't write the set. You guys see that? Because sometimes they're going to give you the equations and they're just going to call it a system of linear equations. Let me give you the third example. Third example, negative 6x plus 3y equals 12 and 4x minus 3y equals 8. All these are examples of system of linear equations. Copy that and I'll go and elaborate a little bit more on this. Copy that. All right. So let me go over this really quick. Write your utensils down. You'll finish copying a little bit. Look up to the screen. It says, systems of linear equations. Systems of linear equations are a set of two or more linear equations that have the same variable. The first example. Do they give us the set? Yes. Here's a little set notation. Two or more linear equations. Do we have two or more? Yes. And do they have the same variables? Yeah. Y and x, x and y. All right. And right now you're just paying attention. Let me go to the second example. What do you guys notice on the second example? It doesn't have the set notation. Is that correct? But it is a system. Negative y equals x minus 5 and y equals 2x plus 1. Let me go to the third one. Do we have two linear equations? Yes. Do they have the same variables? Yes. Now question. What if I gave you and I said all of these four? Will that be a system? Tell your neighbor why it would be a system. Okay, what does the definition say? Two or more. Do we have two or more if I give you all these? Yes. Do they all have the same variables? Yes. So that would be also another system. Everybody understand so far? Now, for those of you that still it doesn't really ring a bell, let me talk to you in regards to music. Know you like music, right? Well, if you install a system in your home, a system requires a stereo and a lot of speakers. That's what we call a system. And it's called a stereo system. Stereo meaning a lot of speakers. Back in your parents' and grandparents' days, there were such things, believe it or not, that only had one speaker. And the speaker didn't have any other sound except just one full sound. When it was one speaker, it was not called a system. It was called a mono radio or a mono whatever. And you guys remember the name mono? From monomials, right? Which means one. That's why this is not called a mono of linear equation. This one's called a what? System, because it's more than one. That means it has to be two or more. Okay, non-examples. Look at this one. Tell your neighbor why this one is not a system of linear equations. All right, it's obvious, right? How about this one? Why is this not a system?
There's no second set.
Okay, we got it? Yes? All right. So, Isaac, this one's not a system because two different variables, x and y, a and b. How about this one, Destiny? I'm sorry? The x and y. Close. Fatima? There's no second equation. We need how many? Two or more. That's why this one's not a system. Therefore, copy this, finish copying whatever you need from here, and come up with at least two hashtags, please. Two hashtags. Copy that. All right. Share with your neighbor at least one hashtag, please.
Hashtag no mono. Hashtag more than two sets.
All right. Let's see. Devin, go. Hashtag what? Two or more what? I don't know about sets. What else can we replace sets? Equations. All right, pass someone. Isaac. Same variables. And one last one, Julian.
Hashtag no mono.
No mono.
No, there's a space between the no and the mono.
Okay.
No.
Like that? No
No.
space mono.
No, just take away the space, but don't erase the mono.
Well, I thought you said there was a space.
There is, like in between.
That's what I did. No mono. There it is. All right. Underneath that, I want you to write steps underneath your prayer model. And for this second semester, guys, now remember first semester, you guys helped me get properties. You guys helped me with definitions, right? This second semester, we're going to focus on you guys coming up with processes and steps. So no longer am I going to be giving you all the time, all the steps so you can write them down. You guys are going to help me come up with that. Now, why am I doing this? Once again, everything we do here is a process. Because next year, when you're at the high school, hopefully, you'll be ready to take notes on your own without the teacher saying, copy this or copy that. Does that make sense? So you'll be sitting in the class, they'll be going over a lesson, and guess what? Some are going to start writing and coming up saying, okay, this property says this, and then you write it in your own words. Then after that, once you finish your lesson, you write, okay, the things that I need to remember. What would be the steps that I need to remember? 3 steps, 1, 2, and 3. Does that make sense? It's all part of a process. You guys needed to develop that. Hopefully by the end of the second semester, you'll be ready to go. Some of you are already there, but I'm saying some of you need a little bit more development in that regard. So today, you wrote steps. You guys are going to help me with the steps. Okay? So with that said, before we get to the steps, though, look up to the screen, write your utensils down. You do not need to copy this. You do need to understand it, not copy it. Ready? Here it goes. So what are we talking about? We're talking about system of linear equations. And the title for this lesson was Solving Systems by Graphing. Okay, so if we're going to be solving, that means a system either has solutions or it doesn't have solutions. Does that make sense? So let me give you the classification. If a system has solutions, that system is called a consistent system. Let me repeat that again. Looking at systems of linear equations, if the system has solutions, it's called a consistent system. However, if the system does not have a solution, tell your neighbor the name of that, please.
Non-consistent.
That is correct. Inconsistent system. Once again, consistent system if it has solutions, inconsistent if it doesn't. Are we there so far? Now, if the system does have solutions, it either has one solution or infinite amount of solutions. If it has one solution, it's called a independent system. How many solutions? One. Or think of it, when you guys grow older, you guys are going to leave your home. Guess what? You're going to become independent. Only one. However, if it has infinite solutions, then it's called a dependent. That's why when your parents do their taxes, now that tax season is coming, guess what you are called when they put you on the taxes? A dependent. You are part of that system. It's infinite amount. So once again, let me recap again. System of linear equation, if it has solutions, is a what? Consistent. If it doesn't have solutions, it's inconsistent. If it has solutions, one solution is independent. No, infinite amount is dependent. Before I move on, explain this again to your neighbor, please. Before I move on, go. All right. We got this, yes? All right. Now get your big graphic paper in front of you. Use the big coordinate plane, and you're going to copy example 1 on the top left. Top left. All right. Example 1. Example 1 says, at the top left of your big graph paper, it says, solve the system by graphing, and then check your answer. And the system given is the set of y equals 1/3 x minus 3 and 2x plus y equals 4. Copy that, please, and I'll go over it. All right? So it says, example 1, solve the system by graphing, check your answer. System given is the set of y equals 1/3 x minus 3 and 2x plus y equals 4. And you wrote that at the top left of your coordinate plane. I'm going to bring a coordinate plane in right here so it can kind of mimic where you're at. All right, so writing utensils down. I'm going to do a think aloud first, and then I'm going to have you guys copy after. So please don't worry about copying. I'll give you plenty of time. So please stay focused. Okay, writing utensils down, look up to the screen. Ready? All right, here it goes. So, example 1 says, solve the system by graphing. Check your answer. So one familiar word that I see here is graphing and solve. I know what a system looks like. Here it is. So, graphing. Do I know how to graph? Yes. Do I know different methods on how to graph? Yes. I know 3 methods. So let's see. Could I use one of the methods for this one? Yes. Now, I think I'm going to use the easiest method as I can. So I like the way it's written here and just graphing that. So that means if I use the same method, I need to change this one. So I'm going to do all right, there it is. Now I'm going to start graphing. So I'm going to graph the first one in one color so I can see the difference from one to the other. So this one, where do I start? At -3. There it is. What else do I need? I need my slope. That tells me 1 up, 3 to the right. 1 up, 3 to the right. 1 up, 3 to the right. And now I can graph my line. And I'm going to stretch my line all the way through the coordinate plane. So I'm done graphing the first one. I'm going to go to the second one. Where do I start? At 4. There it is. And then my slope is 2 down, 1 to the right, 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 2 down, 1 to the right. Then I graph my line. All right. So I think I'm done graphing. And then the next thing is to check, but it says here solve. Now, if I'm solving by graphing, I already graphed. That means that I need to look for the solution of what I see. So I'm thinking that the solution is right here. That might be the solution. So what is that? This is 3, -2. That's possibly my solution because at the end, I need to do what? I need to check. All right. I'll stop my think aloud. Before you copy, talk it over to your neighbor. Let them know what happened up to right there, please. What happened up to right there?
Basically, he made lines from the equation from the system, and basically he went and found the connecting rod to find the answer.
All right. Good combo, yeah? All right, copy that. You have your colors. Make sure you use your colors. I'll give you time for that. Let me pause this really quick. Copy that. All right. So, up to right there. So far, so good. All right. So, up to right there. Show me your fingers how comfortable you are up to right there, even though we still haven't written down steps, but in regards to understanding where we're at so far. Some 4s, 3s, 5s, 4, 4, 4, 4, 4, 4, 4, 4, 4. Okay. All right. So, writing utensils down, look up to the screen. You'll finish copying in a little bit. Okay? All right. Here goes another think aloud. Here we go. So, this says to solve by graphing. So I graphed both equations, and I decided to use one method for both. From there, I'm assuming since I need to check afterwards, I needed to find out something about the graphs, and I noticed they have this in common. So I wrote that. Therefore, to check, I'm given two equations. I graphed them and I found out this. To check, what shall I do with my two equations and this? Talk it over to your neighbors. You have two equations and this. What can I do to check? All right, let's see. Who said that we do what? What is a key word? Substitute into where? X and Y values for only one equation? No, now it's a system that has to be true for both. So check this out. Let's do the next part together. So I'm going to write this first. Y equals 1/3 X minus 3. I'm going to write the second one right next to it. 2X plus Y equals 4. But now I'm going to substitute these values into each. What is my X value? 3. What is my Y value? -2. Let me finish this one first. I'm going to bring everything else down. Equals 1/3 minus 3. So let's see. What is 1/3 times 3?
1.
1. What is 1 minus 3?
-2.
-2. Is -2 equals to -2?
Yes.
Yes, so that is true. So it works for the first one. But now, since it's a system, it has to be true for both equations. So I'm going to substitute on this other one. What was X again? 3. What was Y again? -2. I bring everything else down. The 2, the plus, the equal, and the 4. What is 2 times 3? 6 plus -2. What is 6 plus -2?
4.
4. Is 4 equal to 4?
Yes.
Yes, it's true. Well, guess what? Now that we checked, look what I'm going to do. Look up. I'm going to write solution because now I checked to make sure that was a solution. Piece of cake?
Piece of cake.
Let's go. Copy that, please. I'll give you 30 seconds, and then we're going to go over the process together. Hurry up, please. Act like tomatoes. Let's go to your Cornell notes where you wrote steps, and we're going to break it down by steps. So you're going to, you wrote steps on your Cornell notes.
There we go.
Step number 1. So, look at the entire process. Think about my think aloud. So here it goes. I'm just going to guide you with some of it, but you're going to have to come up with a step. Here you go. So, before I started this, I was given just 2 equations. And I did a think aloud. I read this through, and I asked a question in regards to how to continue in order for me to do this part. Therefore, talk it over your neighbor. Let them know what would be step number 1. What would be step number 1? Okay, so let's see. What would step number 1 be, Michael? Okay, he said isolate the y value. Okay, that would be true for this system and the exact same process that we use for here. But what was the question that I asked before I isolated the y? I said, what methods do I know to graph? Wasn't that the question? Yes. Therefore, what would be step 1? Talk it over to your neighbor again. What would be step 1? All right, Paul, go. Choose a graphing method. That is correct. How many methods do we know, everyone? 3. Now, I went with the one I like the most, which is slope-intercept form. However, look at this second equation. Look up. Look at the second equation. What would be another method, easy method, that I can use to graph this second equation other than slope-intercept form? Everyone. Cover up, right? If we cover up the x, what do we have left? Y equals 4. We plot that there. Cover up the y, solve for x, divide by 2, x equals 2, and then we graph that line. Does that make sense? So we choose a method. All right, let's go to step 2. Everyone, step 2. Everyone, step 2. Okay, once again, we chose our method, okay, whichever method we choose. Step 2. Graph. That is correct. When we choose a method, that means we need to, if we chose slope-intercept form, that means we need to do what we need to do. What did we need to do to make it a slope-intercept form? Well, we need to subtract 2x and so on and so forth. That's choosing the method. Step 2, we graph. All right, so we graph. There it is. What was the third thing we did? Tell your neighbor, third thing we did. Haley Ann, go. That would be step 4. Step 4 is check. Mel, find the intersecting point. That is correct, comma. I found it. Now, to find it, you can just say, oh, it's right there. But physically, what did I do? Continue, comma.
Make lines.
No, the lines are already graphed. And I found the point. It's right there. What do I do? Marissa? Okay, so before I write out the coordinate, what did I do? Brody. Plot, comma, and write the coordinates. Now that's up to right there. we're good with a possible solution, and once we check, that's when we write our solution. Is that correct? So let's see if the process makes sense. Choose a graphing method. Does that make sense?
Yeah.
Yes, because we know 3 different methods. Who wants to use the table for these? Okay, good. Step 2, graph. Step 3, find the intersecting point, plot, and write the coordinate. There it is, and at the end, check. We got this? All right. So let's see how you do by yourself. Ready? Oh, and before I move on, look up. There's one solution. What would be the name of this system? Name of this system. Tell your neighbor, please. What would be the name of this system?
Independent.
One solution. Mel. Independent. What else? What's another name? Yes. No, it's independent. We're done with independent. Jason. Close. Constant. It's a constant because there is a solution, and it's independent because there's only one. Okay? So your home play for tonight. Home play for tonight is on pages 281 through 282 only. There is tutoring today. I don't see you. See you guys tomorrow. Bye.